Hi. In this video, let's see the problems based on extreme values of a function of two variables. So we have extreme values means either it could be a maxima or it could be a minima. So they're asking you to find the extreme values means find the maximum value and the minimum value. So far you would have seen this in one variable. Now we are going to see in two variables. One variable means, see, for example, we are having a graph which has a point like this. So this point is the maximum point. Same way in the graph like that, there will be many lowest point. These we call it as a local minima. Like that, the same graph, you may have a local maximum as well as a minimum as well as the saddle point in one variable. Now it's a 2D graph, two variables means, see these graphs. Now if you see this part, this gives a maximum and this gives a minimum. Same way, in between the, now see this graph, in between the maxima and minima, there is a point that comes like this. This will give you the saddle point. So saddle point is a point on the surface of the graph where the tangent plane is horizontal, but the point is neither a local maximum nor a local minimum. So now I'm saying that this is a maxima and then this is also a local maxima. Now, how do I identify these points in one variable or even in two variable? If you see the slope at this point, that is the dy by dx is 0. So the first way to identify the local maximum is, or the local minimum, is the slope at these points are 0. Then I look into the second derivative and I will segregate whether it's a local maxima or local minima. So these are all 2D graphs. If you see this equation, these are all 2D graphs where you can have a feel of what do you mean by a local maximum or a local minimum or a saddle point. Now let's go into the problem. Now see this question. We have to find the extreme values of this function. Now, as I told you, in single variable, we will find the first derivative. Here it is a function of more than one variable. So I cannot write dx by dy. This is wrong. Or dy by dx. So here I can say either the given function f with respect to x, I have to make it 0. And I have to differentiate the given function with respect to y and I have to make it 0. So now with respect to x and y means, keep this in mind. If I'm going to differentiate with respect to x means all these y square, 3 and everything is a constant. Okay. And you see the number 4. Now I'm treating 3y square and 4 as the same. Just refer the basic concepts of partial differentiation. So del f by del x is x cube differentiation is 3x square plus, now 3y square is a constant and this x differentiation is 1 and then minus 3x square. So with respect to x means 3 into 2x, which is nothing but 6x. Okay. And this is pure constant. If I differentiate a constant, I'll get 0. I'm treating 3y square and 4 same. So del f by del x is equal to 0 means 3x square plus 3y square minus 6x is equal to 0. Let it be in one side. Now I'm going to find del f by del y. I'm going to partially differentiate with respect to y. Now if you see here, what are the terms, these x terms, now whatever I'm circling in red is a constant. So x cube, if I differentiate, I'll get 0. So better not to write, or I'll write 0 plus. Now if you see, this x is going to be a constant because this time I'm differentiating with respect to what? Y. So x is a constant. So 3 is also a constant. I will write 3x. Y square differentiation is 2y. Okay. And if you see the next term, with respect to y I'm seeing, so this is pure constant. So this is 0. And then minus 3y square if I differentiate, minus 3 into 2y. And the last term is pure constant. So the whatever I've marked in red, anything other than y is a constant for me. So del f by del y is equal to 0 means 3 2s are 6xy minus 6y is equal to 0. If I substitute del f by del y is 0. Now we have got these two equations. Okay, by using these two equations, I'm going to find the points that is, let me choose the color, 1 second. Yes, so let me solve the equations. We have 3x square plus 3y square minus 6 is equal to 0. And if I simplify this, what is this? 3 into x square plus y square minus 2x is equal to 0, right? This is 3x square, 3y square minus 6x. So if this is 0 means, if 3 goes to the other side, I will take x square plus y square minus 2x is equal to 0. Similarly, from this side, if I take 6 common, xy minus y is equal to 0, which implies xy minus y is 0, because 0 by 6, anything by 0 by anything is 0. Now your equation is even more simple. If you take y common, y into x minus 1, 0, which means y is equal to 0, x minus 1 is equal to 0, which means y is equal to 0, comma, x is equal to 1. So now what I will do, this let it be equation say 1. So from this equation, from 1, if y is equal to 0, then if I substitute, x square minus 2x will become 0. X into x minus 2 is equal to 0, which implies x is equal to 0, comma x minus 2 0, which implies x is equal to 0, comma x is equal to 2. Now if I substitute y is equal to 0, I am getting two combinations. This is on the other side. This is on the other side. Now I am seeing the two combinations. What are those combinations? X 0, y 0, because this is x, this is y. X 0, y 0, and then x2, this fellow, and then y 0. So we have got so far 2 points. Okay. From substituting y is equal to 0 in the given equation. Okay. Now I am going to substitute x is equal to 1. Put x is equal to 1 in equation 1. If I substitute x is equal to 1 in this equation, 1 plus y square minus 2 is equal to 0, which implies y square is equal to 2. Okay. If I take this equation, let me rewrite this. Yeah. So y square is equal to 2 minus 1, which is 1. Y square is equal to 1 means y is equal to plus or minus 1. Now what is the second combination when y is equal to 0? This is the combination 1. Same way, either y is equal to 0 can happen or x is equal to 1 can happen. So when x is equal to 1, what are the points we are getting? Y is equal to plus or minus 1. So 1 comma plus 1 is one combination and 1 comma minus 1 is another combination. So these are the stationary points. Always solve one equation. What are the combinations you are getting in that first equation? Substitute. Stationary points are, let me explain. Be careful when you are taking the stationary points. We've got two equations, correct? From the second equation or from the first equation, it's our wish. Here it is easy for me to solve from the second equation. So from the second equation, I have taken y is equal to 0, x is equal to 1. My combination 1 is, if I put y is equal to 0 in equation 1, I am getting x as 0 and x as 2. So we are going to write two combinations, x0, y0, x2, y0. Now this second x is equal to 1, I am substituting it. When I substitute x is equal to 1, I am getting two answers, that is plus or minus 1. So plus 1, x is equal to plus 1, y is equal to plus 1 is one combination. X is equal to plus 1 and y is equal to minus 1 is the other combination. Therefore, we get 4 stationary points, that is 0, 0 and 2, 0, 1, 1 and minus 1, 1. Now what we are going to do is, we are going to find now these are stationary points, means it could be a maxima or a minima or a saddle point. Okay. So now I am going to find whether it's a maximum point or minimum point by using the second derivative. So we are going to differentiate fx again with respect to x, that is a, and then again with respect to y, that is b, and c is f again with respect to y. So let us find what is a, b, c. A is fxx. I have written all the values, that is del by del x of fx. This is your fx. So what is with respect to x3 x square differentiation is 6x. Only with respect to x. So y is a constant, this is 0. Then minus 6x if I differentiate, minus 6. This is the answer for the first one. If I differentiate this, you can write it anyway. Fxy and fyx is same for this problem. So del by del y of 3x square is 0 first term, because with respect to y means x term is constant. 3y square is 6y. Again, this is with respect to x, 0. The partial mixed partial derivatives are equal. So you can do it the other way also. Del by del x of fy also you can do. You'll get the same answer. And then the next one is fyy. We are going to differentiate partially with respect to y, and this I have written fy. So 6x is a constant. Y if I differentiate 1, so I'll get 6x. And then 6y if I differentiate, y differentiation is 1, we are getting minus 6. That's it. Now we have got a, b, c. Now we are going to find ac minus b square for all stationary points. So what I will do, I will write it as a tabular column and we will discuss the case. So these are the values, that is a, b, c that we found, and we have to find ac minus b square. So first 6x minus 13, that put x as 4 and y as 0. So what you will get here, 6 into 4 minus 30. So 24 minus 30, we are getting minus 6. Same way 6 into y is 0. So 6 into 0, we are getting 0. C if you see, C is equal to 6 into 4 minus 30. 6 into 4 minus 30 is again minus 6. And then finally AC minus B square. A is minus 6, C is minus 6, then 6 into minus 6 minus 0 square. So A is also minus 6, right? So minus 6 into minus 6, it is plus 36. So we have got AC minus B square. Now what we have to check means, if AC minus B square is greater than 0 and if A less than 0, this maximum point how I am writing is, if AC minus B square greater than 0 and A less than 0, we call it as a maximum point. Okay. Same way, put x as 6 and y as 0 in this. So what I will get, 6 into 6 minus 30. So 36 minus 30 plus 6 greater than 0. And then 6 into y, 0. Then now here 6x minus 30. So what we are going to do, 6 into 6 minus 30. So 36 minus 30 plus 6. Now we are checking. 36 is greater than 0 and 6 is also greater than 0. So here we are writing minimum point. Why? Because here in this condition, AC minus B square is greater than 0 and A is also greater than 0. I am not getting it. So this is the second case. Both are greater than 0. Now see the third case, 5, 1. So what you will write, 6 into 5 minus 30. 6 into 5 is 30 minus 30, 0. The next one is 6 into 1, 6. Then 6 into 5 minus 30, again 0. Now if you see here, the third case, that is your AC minus B square is less than 0. If it is less than 0, then we call it as a saddle point. Same way, if you substitute the last point, you are getting less than 0. Hence, it's a saddle point. So keep this in mind. If AC minus B square greater than 0 and A less than 0, it is maximum. AC minus B square greater than 0 and A greater than 0, minimum point. Finally, you have to substitute X and Y values to find the maximum and minimum values. So from the above table, for 0, 0 only, we got the maximum point. So here, put X as 0 and Y as 0 in the given question. So because of this, all these terms will become 0 because both x and y. So we are getting 4 as a maximum value. Similarly, minimum values, put x as 2, y as 0 in the question. We get 2 cube and then 0 minus 3 into 2 square, which is 12. 8 minus 12 plus 4. This gives the minimum value. Thank you.